In this video, we want to look at transforming graphs using multiple transformations at once. So what we've got at the minute is y equals sine x using it's measured in radians. So it has a root of pi 0 and 2 pi 0. Its period is 2 pi, and it is a maximum value of pi over 2 and 1, and a minimum value of 3 pi over 2 and minus 1. If we are doing multiple transformations at once, what we're thinking about is something like a f of x and then plus b. So we want to think about, well, what happens to a, what happens to the graph, and in which order does it work. So if we change these to 2 and 1, so the effect is being a is doubling things, and b would be moving it to the left by 1. And in this case, if we move it to the left by 1, so if we move it to the left by 1 and then double its height, that's not going to be any different to doubling its height and then moving it to the left by 1. So we can try that with a different point. So pi, if we move that to the left by 1, that's going to be pi minus 1. And then doubling it, it would go to pi minus 1, 0, which is 2.142. This has a maximum point of pi over 2 and 1. If we could get to show that. And whenever we move that to, if we double that, it will go to pi over 2 and 2, and then move it to the left by 1. So in actual fact, whenever it's a f of x plus b in this format, it doesn't matter the order that it goes in. But generally speaking, if we still do the brackets first, we move it left first of all and then scale it, that's going to be more true to form. And that would be the same if it was, rather than plus b, it was bx. It's the same idea. So here we'd multiply it horizontally by a factor of 1 over b. So if we change that to 2 as well, we're halving it. So it's being, we're squishing it in the way by a factor of a half. And we can see that there are 2 full graphs within one period. And then it's also been stretched vertically by a factor of 2. And it doesn't matter which order we do those. We can stretch it horizontally and then vertically, or vertically and then horizontally, and we'll still get to the same point. So we'll still get from the maximum value to the maximum value, either way round that we do it. So we could double it in height, and it would go to pi over 2, 2, and then we'd shrink it by a half to get pi over 4, or we could shrink it to get pi over 4, 1, and then double it to get pi over 4, 2. So the order doesn't matter in this case, but what we would tend to do is just stick with BuildMath or BidMath and do the brackets first, and then everything after that. If we were to add a C to this, so add another slider, then the order does matter. So in terms of the plus C, anything outside of the function should always be done at the end. So whenever we're doing this, B stretched it to the left by a half, stretched it in the way by a half, then A stretched it vertically by a factor of 2, and then plus C has moved it up by 1 in this case. So we had moved it left by a half, up, we've doubled it, and then moved up by 1. So this has a height of 1. So this, whenever we double it, would go to 4, and then move it up 1. Or, sorry, double would go to 2, and then up 1 would go to 3. Whenever we think about the values at the minimum, so the minimum here is 3 pi over 2 and minus 1. If we shrink that to a half, that will take it to 3 pi over 4 and minus 1. Then doubling it would go to minus 2, but then adding on 1 would take it back up again to minus 1, which is where that's going to. So plus C at the end, do it last. The other two doesn't really matter, but generally if you follow BuildMath, so brackets, multiplication, division, and then addition and subtraction math.